This video will be a test review, which will discuss simplifying and solving rationals. I'm going to have 10 examples. You can skip through the sections that you need to if you already understand certain examples. So for example 1 and 2, I'm asked to simplify each of the expressions as well as state the excluded values. So I personally like to put everything in factored form. That way I can cancel out anything or simplify further if need be. So on example 1, for my numerator, what I'm going to do is take out the greatest common factor of 3, and I am left with 3v plus 1. We factored so much, so right now you should understand where that came from, but in the event that you don't, the 3 that is on the outside, I just take each term 9v and the positive 3, and I divide both by that 3, and what's left over goes inside of my parentheses. So what's inside of the parentheses is an expression that has to look exactly the same on both the numerator and the denominator. In this case, you do not see anything in the denominator that looks like that expression, so I cannot mess with it. What I can do is look at the numbers that are outside of the parentheses, and in this case, there's a 3, and on the bottom, there is a 24. So if I were to simplify the 3 and the 24, now my answer is going to be what's left over, and that's going to be 3v plus 1 all over 8. That's my final answer. The directions ask me to state the excluded values. The excluded value means what can the denominator, what will make the denominator equal 0? Well, since there is a number there, there's nothing that can make that number equal 0. But had it been 24b, then if we put a 0 in for the variable, not b, v, if we put a 0 in for the variable v, then that will be the excluded value, because 24 times 0 would have made the denominator 0, and we couldn't have that. So in this case, since there is not a variable, it's just a number, then there is not an excluded value, so none. And I'm not even going to put that v equals. All right, so, or I could just write no excluded value so it's clearer. And that's what we're going to do. No excluded values in this example. All right, if I move on to the next example, I have a numerator that can be factored. So I'm going to go ahead and take out the GCF, or greatest common factor, of 4. And what's left over when I divide each term by that 4 is b plus 4. And again, you can just double check it by distributing it. If you did that, you're going to see 4 times b is 4b, and 4 times 4 is 16. So that is the correct factored form. And now in the denominator, those are big numbers, so you don't want to try to factor it. You want to try to take out the GCF. So in that case, which is a portion of, it's a step in factoring, but let's just do that first. So take out the 5, and what's left over after I divide each term by that 5 is b squared plus 2b minus 8. And again, just distribute it back out, and that will give you your answer. I mean, it will give you the standard form. You're just rewriting it. So let's see if we can further simplify that, and you can. So I have, inside of the parentheses above it, b squared. And what times what is going to give me b squared is b and b. And then what times what will give me this negative 8, but will also add to give me a positive 2, which is what's in the middle. Well, that's going to be a positive 4 and a negative 2. We've already talked about factoring, so I'm not going to go over that, but I do have videos on it if you needed to. In addition, I have to bring down that GCF that I already had, which was 5. So that is me rewriting that rational expression. So now what I want to do is see if I can simplify anything, and I can. On the top, I have a b plus 4, and on the bottom, I have a b plus 4. So top to bottom, you can simplify. What's left over after I finish doing that is 4 on the top, And on the bottom, I have a 5 times the quantity of b minus 2. So that is my final answer, but my instructions also asked me to figure out what the excluded value was. So my excluded value is based off of my original denominator. What would happen? What number can I not put there because it will cause my denominator to equal 0? The easiest way to see that is to look at it in factored form. So if I'm looking at the factored form, I have a b plus 4. If I set that equal to 0, then b cannot be negative 4. And if I set the b minus 2 equal to 0, b cannot equal positive 2. So my excluded values are negative 4 and positive 2. If I were to substitute either of those numbers into my original denominator, it's going to cause it to equal 0, which is undefined. We can't have a 0 in the denominator. Example 3 and 4. These are, well, they're asking me to simplify the expressions. I have like denominators. So these are the easier simplifying expressions type problems. If my denominators are all already looking the same or they're the same, all I need to do is just put it in one big fraction. So 9k cubed plus 45k squared. Computer's getting hot, so it's acting up. So once I put it all together, all I have to do is just combine what's on the top. And since there's a plus sign, I don't have to worry about changing any signs whatsoever. I'm just going to take both of my k's. I have a k plus another k, which results in 2k. And then I have a negative 1 and a positive 3. If I combine those together, I'm going to end up with a positive 2. And I already have my fraction. So in some, it depends on your teacher. Some teachers are okay leaving it like that. You could also, if you wanted to put it in factor form to make sure you have nothing to simplify from top to bottom, it is 2 times the quantity of k plus 1 if you were to put it in factor form. And then on the bottom, you can take out 9k squared and you would be left with k plus 5. And as you can see, both of those expressions are different. So there is nothing that you can cross out. So either of those answers would work. And the directions didn't ask us to look for anything else. So we're finished with that. Moving on to example 4. Now, what you want to do here is you want to pay attention to the sign that's in between because that does affect something. If I have a subtraction sign, it's going to affect the numerator of the second fraction only. So what I want to do is I want to go ahead and rewrite this by making that a plus sign, putting a minus sign in front of that numerator. However, since it's an expression, it has to apply to all of the terms. So I'm going to distribute that negative sign to everything. So when I rewrite it, I have one big fraction bar, 5b minus 5. And then on the top again, I'm just combining like terms. I have b minus 5. Don't do plus minus, just do whatever is shown in your numerator. So that's now negative b minus 1. I'm going to combine my like terms on the top. So I have b minus b, which is just 0, and then negative 5 plus negative 1, which is negative 6, all over 5b minus 5. So again, technically you're finished, but it just depends. If you wanted to put it in factored form, then the top is still negative 6, but the bottom, if you take out the GCF of 5, you're left with b minus 1. And as you can see, there is nothing for you to simplify. So those are 2 acceptable answers. If I go to my next examples, 5 and 6, this time I have uncommon denominators. When you have uncommon denominators, you can use a method known as the butterfly method. Do not try to use that when you have a common denominator or like denominator. That's going to just cause all kinds of problems. So what you want to do is, first off, again, make sure, look at what sign you're working with. We're working with the positive sign or plus sign, so I don't have to change any signs here. My wing for my butterfly will start from the top going down to the bottom. And what I'm going to do is multiply that. So everything that I'm doing for my wing is going in my numerator. 2 times 3x is 6x. And on the other wing, I'm going to go like this. And again, I'm multiplying. Now if you notice in the first fraction's denominator, it's an expression. So what's really going to be happening is I'm taking the 2 from the numerator of the second fraction and I'm multiplying it times all of that expression that's in the first fraction's denominator. So this is what I'm doing. And so I'm going to have plus 12x squared plus 24x. And now on the bottom for me, what I like to do is just go ahead and put this in factored form. So this is, I'm going to take out a 6x. I'm left with x plus 2. And on the other side, I just have 3x. Well, what's on the outside, I want to multiply that together. So I have the 6x and the 3x, which results in 18x squared. And that's multiplied times the quantity of x plus 2. So now I already have the factored form of that. If I go back to the numerator and I rewrite it in standard form and then combine like terms, I'm going to have 12x squared. And then I have 6x plus 24x, which is going to be plus 30x. All over 18x squared times the quantity of x plus 2. I can further simplify the numerator. So actually, let's just, instead of scratching through stuff, I am going to rewrite that by taking out the greatest common factor. And the greatest common factor here is going to be 6x, because I can divide both of those by 6x. And then what's left over is 2x plus 5. And at the bottom, I have 18x squared times the quantity of x plus 2. So what I notice is my expressions that are in parentheses are not exactly the same, so I cannot touch anything in it. What I can touch is what's on the outside. I can simplify 6 and 18, and that will result, if I divide both by 6, I'm going to end up with 1 over 3. And I can take one of these x's away and one of these x's away, which leaves me with just one x at the bottom. And when I rewrite that as my final answer, what's left over at the top is 2x plus 5 all over 3x times the quantity of x plus 2. Again, I cannot simplify any further because there is nothing on the top that looks the same as what's on the bottom. So that's my final answer using the butterfly method. I forgot my little butterfly. There we go. And that. Now, if I go to one that it's still using the butterfly method, but this time I'm going to be subtracting, then what I want to do is make sure that I change that sign that's in the middle to a plus sign, and I just can't get rid of the minus sign. I have to actually apply it somewhere. Since there's an expression over on the numerator of the second fraction, I have to put it in parentheses, and I'm going to end up distributing that negative sign. So I might want to go ahead and do it now so I'm not confused here in a few minutes. So that's what I'm going to do. I'm just going to rewrite it before I do my butterfly. And that ends up being 5 over 2r plus negative r plus 3 all over and 2r minus 6. If I do my butterfly method, I'm going to go this way. And now since I changed it to a plus sign, I don't have to worry about changing signs anymore because I've already done that. And when I multiply it out, remember, this is really me saying 5 times the quantity of 2r minus 6. So I'm going to have to distribute. I end up with 10r minus 30. And again, all of this is on my numerator. I have to do 2 things on my numerator. So now I go to the other side. And I'm going to do the same thing, but this time I have 2r times negative r plus 3. You could have also made it negative 2r times r minus 3. It depends on how you see it. And now once I do that, I have negative 2r squared plus 6r. Now on the bottom, what I want to do is I want to rewrite in factor form whatever I can. This one, I can't do anything, so I'm just going to leave it as 2r. Over here, I can take out a 2, and I'm left with r minus 3. So since I have two things on the outside, or this one doesn't even, the first one doesn't even have a parenthesis, so I just multiply those and I combine them together. So that will end up being 4r on the outside times the quantity of r minus 3. I want to go back to the numerator, rewrite it in standard form, and then combine like terms. So I have negative 2r squared. I have a 10r and a 6r, so that's 16r minus 30 all over 4r times the quantity of r minus 3. I see on the top, I can take out a negative 2 as my GCF, and I'm left with r squared minus 8r. Pay attention to the signs. They will change once you take out a negative sign, and then plus 15. All of that is over 4r times the quantity of r minus 3. If I look again, I can see that I can still factor even further. So I have negative 2, and r times r is going to give me that r squared. And now I need to try to figure out what will give me 15, but also add to give me negative 8. Well, I know 5 times 3, but that's not going to give me a negative 8. That's going to give me a positive 8. So I need to change the signs. So I have a negative 5 that's going to go here and a negative 3 that's going to go here. And that meets my criteria. At the bottom, I still have that 4r times the quantity of r minus 3. And what I will notice is I can actually simplify the r minus 3 factors. And if I look on the outside, I have a negative 2 on top and a 4r on the bottom. So I can simplify that. And that leaves me with, by dividing both by 2. So that's negative 1. And then 4 divided by 2 is 2. Rewriting that so that it's not all messy, I am left with on the top negative quantity of r minus 5 all over 2 times r. Now, it depends on who's actually, again, who's doing the worksheet or the test. They may leave it like this, or they may distribute it out, and that will be negative r plus 5 over 2r. So either way is acceptable. Okay, moving on to example 7, which is I am asked to simplify each and state the excluded values. And this time we're multiplying and dividing. We're using the techniques we already know. So when you are canceling or simplifying, you can simplify up and down, diagonally, both directions, but you cannot simplify going left to right, horizontally. So when you are multiplying, you're going to multiply the numerator times the numerator, the denominator times the denominator. Before you do that, you want to try to simplify it as much as possible. So 1 over 3x minus 2 is in its simplest form. If I look over at the numerator, and so is this denominator, x plus 1. But if I look at this numerator, that can be factored. The easiest way to look at that is to look below to see if there's anything that could possibly be a factor of the polynomial that you're working with, and also look diagonally to see if that could be a possible factor. So I'm going to try diagonally. I'm going to use that 3x minus 2 in hopes of that being one of my factors. So 3x times what will give me 3x squared? Well, we know that's x. Negative 2 times what will give me positive 12, and that is going to be a negative 6. Well, we don't know for sure if that's going to add up to give us the negative 20 that's in the middle. So what you can do is a sad face. In this case, if it was on the bottom, I would say a happy face, and then another sad face. So 3 times negative 6 is negative 18x. And then in the middle, negative 2 times x is negative 2x. And if I were to combine them, I do, in fact, get the negative 20x. So I know that those are my factors. What I want to do now is start simplifying as much as I can. Diagonally, I can get rid of something. I don't see anything else to get rid of, so now I just follow my operation, which is multiplying 1 times x minus 6. That's what's left over. And then this becomes 1 times x plus 1. So that's all that's left in as far as my simplified form. And then we were asked to include the excluded values. So in this case, x cannot equal, and again, I want to look at my original denominators. What would make x equal 0? So the easiest way is to change the sign of the constant and divide it by what's in front of your x. So x cannot be 2 over 3, or you can set it equal to 0 and solve. So if you set it equal to 0, what would that end up being? That's going to be divided by 3, what I just said. So x cannot be that. And then you go to the other one, and it's the opposite sign, or x plus 1 equals 0. So that means that x cannot be -1. So those are the two excluded values for this problem. Moving on to problem 8, I have a division problem. So division, just think of dollars. And so division, dollars, they both start with a D. And the reason I'm thinking dollars is because maybe we want to go to KFC, the restaurant. Well, the way that you probably learned it in the past is keep, change, flip, but I say keep, flip, change, but it's whichever way you want to see it. Keep meaning keep your first fraction exactly as it is. Change means change your division sign to a multiplication sign. Flip means take the reciprocal, and you're going to move the numerator and the denominator. So for the sake of just doing multiple steps at one time, when I flip it, this 4n plus 4 is going to go to the bottom, and I'm just going to go ahead and put it in factor form. So I'm going to take out the greatest common factor of 4, and I'm left with n plus 1. And in terms of the numerator, it's now going to be that 2n squared plus 8n plus 6. I want to take out the greatest common factor of 2, and I'm left with n squared plus 4n plus 3. And I can further factor that, so we will keep going. We'll rewrite the first fraction. And it's 2 times, and again, I see n squared, so I know it's going to be an n times an n. And then I see a 3 that has to add up whatever the factors of 3 are. There's only 2, it's 3 and 1. So plus 3 and plus 1, and they have to add up to give you that middle term, and they do. 3 plus 1 is 4, all over 4 times the quantity of n plus 1. And now I want to start simplifying as much as possible. So I see the n plus 1s can go away. I see that the 2 and the 4 will leave me with a 1 over 2. And again, it's getting messy, so let's just move on down to the next step. Multiplying across, I have 2 over, let's just do one thing at a time. Multiplying across the top is just going to be 2 times n, the quantity of n plus 3. That's all that's left over. Everything else on the top is crossed out. On the bottom, I have a 3 times a 2, which is 6, and then I have n squared. I can further simplify that because 2 over 6 is going to give me 1/3. And so therefore, what's left on the top now is n plus 3, and I'm left with 3n squared. Now, don't forget, this is all one expression, so I cannot try to get rid of the n's, and that's a common error. If it's an expression, it has to look exactly the same on both the top and the bottom. So we were also asked to find the excluded values. Going back to my denominator, my original denominator, the only thing I cannot put there is a 0, because 0 times 3 is going to result in me having a 0 in the denominator, which we can't have. Looking at the factor form of that original denominator is really this. So we know that the n here cannot equal -3, and the n here cannot equal -1. or it will in fact give us a 0. So remember, that was my original denominator. So that's why I'm looking at that. When we are dividing, we also have to look at the second fraction's numerator only, because guess what? It's now a denominator, but we've already accounted for it because the n plus 1 is the same. So we've already accounted for that -1. That is an excluded value, so it cannot be any of those three numbers. Okay, I have two more, and they're solving. So for example 9, I'm going to solve the equation, and I'm going to make sure that I can use whatever that variable is equal to, because it's not an extraneous solution. Extraneous solution is another way of saying excluded values. So for me, this is the way I do it. There are multiple ways to do it. I'm looking at my denominator. I want them to be a common denominator, but since they're separated by an equal sign, I see over here that I have 2a plus 12. But if I were to put that in factor form, that's really 2 times the quantity of a plus 6. Well, I see those two things over here already. So that tells me that that is my least common denominator. Excuse me if I say greatest, because I always say that. I don't know why. That's my least common denominator. So I'm just going to go ahead and write a plus 2 all over 2 times a plus 6. I want it in factor form. Equals. Now, I told you above that if you have an uncommon denominator, you can do the butterfly method. That's what I'm going to do only for this side. I don't want to cross over the equal sign doing that. So on this side, I'm going to use that butterfly method that I told you about earlier. And so this is what it's going to look like. At the bottom, we already know is 2 times the quantity of a plus 6. On the top, 1 times a plus 6 is a plus 6. We're going to change this negative to a positive, and then we're going to distribute this negative to everything that follows. Or I could just take the negative and apply it to the 2 that's in the first fraction's denominator. It's going to give you the same answer. So 2 times negative 3a is negative 6a. And then that negative is going to change the negative 6 to a positive 6. And that positive 6 has to multiply times the 2. So that's going to be positive 12. Or you could have said negative 2 times negative 6 is still positive 12. Now what I want to do is I want to combine my like terms. So I'm just going to keep bringing this one down. 2 times the quantity of a plus 6 is equal to negative 6a plus 1a is negative 5a, and then 6 plus 12 is 18, all over the quantity of 2 times a plus 6. And when I am solving, I want to get rid of the fraction. So I want to make sure that I am going to end up multiplying both sides by the denominator. So I'm going to multiply, I'll just do it separately. So what I do to one side, I have to do to the other. I want to get rid of this denominator, so I have to multiply times 2 times the quantity of a plus 6. And again, what I do to one side, I do to the other. In doing that, what's going to happen diagonally, because really this is over 1, right? So diagonally, they look the same. I can get rid of it. So what's left over is the a plus 2. And that's set equal to negative 5a plus 18. Now I want to combine like terms. I want to put all the a's on one side and all the constants on the other. So I'm going to add 5a on both sides. And at the same time, subtract 2 on both sides. That way, on the left-hand side, I get rid of the constants. On the right-hand side, I get rid of the variables. And now I combine. I have 1a plus 5a is 6a. And then 18 minus 2 is 16. And now I want to solve for a by dividing both sides by that 6. That's stopping a from being by itself. And a can further be simplified because 16 and 6 are both divisible by 2, which leaves me with 8 over 3. So that's my final answer. And before I box it, normally I would go and check my extraneous solution, but I already know that it's not, that 8 over 3 is fine. So my extraneous solution, again, comes from my original denominator. If I go to my original denominator, a cannot equal -6. I cannot have a -6 here because that will make that 0. And if I try to put a -6 there, it would also make it 0. There is nothing that will change the 2 to a 0. So I don't even have to worry about that one. So that's the answer. And this is the last problem. So here I see on the right-hand side, my denominators are already common. I do not use the butterfly method when that's the case. So I just bring down 6 over n minus 1, and I just make this one big fraction bar. I personally like to put it in factor form. So n times n is going to give me the n squared. And then to find the plus 3, we already did that a few minutes ago, is 3 times 1. But this time, instead of a +4, we need a -4. So therefore, the signs will have to actually change to a -3 and a -4. So that's my new denominator. And now I just combine the numerator. Since there's a plus sign here, I don't have to worry about changing any signs. So I have n, and then 4 plus 1 is 5. Now I want to go to that step that I just did a few minutes ago. My whole point in solving is to get rid of this fraction. So I need to get rid of the denominators. So what I want to do is I want to multiply both sides by -3. And I'm sorry, the quantity of n minus 3 times the quantity of n minus 1. What I do to one side, I do to the other. And what I'm going to notice on the right-hand side is the entire denominator goes away, and it just leaves me with the n plus 5. And on the other side, only the n minus 1 goes away. So let me go back here. On the left-hand side, I have 6 times the quantity of n minus 3. On the right-hand side, I simply have n plus 5. I have to distribute that 6, and I'm left with 6n minus 18 is equal to n plus 5. And again, I want to combine like terms, so I subtract n on both sides. I add 18 on both sides. That way, my constants on the left-hand side go away, my variables on the right go away. 6n minus 1n is 5n, and 5 plus 18 is 23. I want to divide both sides by that 5. And I see that n is in fact 23 over 5. And let's just double check to make sure that it's not an extraneous solution. N cannot equal, in this case, a +1. And then here it's kind of hard to see it. So therefore you want to look at it in the factored form. And you will see that n cannot equal a +3. And we've already said it can't equal 1. So that is how you actually solve and check for extraneous solutions when we're talking about rational expressions. That was a lot. Hope you had a better understanding of it. Don't forget to like and subscribe. Have an awesome one.